We're going to talk about this device that I built. It's for a simple purpose that we required a gas bottle to be shut off despite the testing device's requirement. The testing device would attach to a CO, carbon monoxide detector, and it would feed gas into the detector, but sometimes the relay wouldn't shut it off. So devised this system to overcome that obstacle by using a gas solenoid, an air solenoid, and it's a simple 12 volt actuated air relay. So this was the perfect solution, and to control it, basically wanted to make it so that when testing began, you would simply press a button and would allow this relay to open, allowing the gas to flow and the testing to be completed. And once the testing was completed, if you forgot to shut off the gas bottle, because that's what we do is we shut it off after every use, but sometimes you get distracted or disturbed, whatever, and you can't make it back in time, then you can shut it off. This unit will shut it off, and it will actually alarm you. It'll send a warning alarm to go back and recheck and make sure that you shut that bottle off. So to go over the system, it's pretty straightforward. The hardware, like I said, we have this 12 volt 2.5 watt solenoid, draws 200 milliamps, which you wouldn't be able to run off of microcontrollers. You would need a pilot relay to activate this relay. Or you could possibly use a transistor or MOSFET, something else to control it, but I preferred to use a relay only for the simple fact that they're quite simple to set up. So if we just go in here and have a look, what I have for the hardware side is we have a wall wart in the background. It's a plug-in 12 volt DC power supply, and we have an Arduino Nano, which is supplying the control structure for activating all the timing and the controls for everything that's in here. We have a 5 volt step down IC chip. It's the LM7805, and it basically takes pretty much, I think it's up to 25 volts, and will bring it down to a 5 volt regulated voltage, which the Arduino Nano requires. We also have a 5 volt relay. This is our pilot relay, and we also have a 4 to, I believe it's a 12 volt buzzer. On the control side, we have power LED, a test LED, test button, and an alarm reset button. And it's all housed in this case. The pilot relay was simply purchased locally at a robotics shop in Markham in Ontario, and this is quite a good little model here. It was about $5, and it has an optical separator. This will do up to I believe 120 volt AC at 10 amps. So it has the optical isolation. It has a VCC, ground, and an in. I didn't realize this until after I purchased it, that it is actually a ground trigger. Trying to feed it 5 volts will do absolutely nothing, but as soon as you ground that input, the relay will trigger. And I'll just show you a quick demo of how this unit works. basically, when the Arduino is powered up, there's a statement in there, basically to turn the digital output to high, which would send 5 volts, and I have a set of resistors in here to control the voltage of the LEDs, because they don't want 5 volts, they want, I believe it's 2.5 to 3.5 volts, somewhere around there. I worked it out. So I have some resistors in there, and 5 volt comes out and it lights up the power light. And when you hit this begin test, it sends 5 volts back to the digital input, and what's happening there is the light comes on to verify that's another output. So once that switch is seen, it turns on the light, turns on the power pilot relay, which in turn switches that 12 volts and turns on the valve. I have it set up so that it's a 5-minute countdown, and after 5 minutes the alarm will sound, and possibly by the time this is done you will hear it. Moving forward in the future, I think I might actually use one of these. This is actually something I picked up off eBay. It's got a built-in voltage regulator for, you just feed it whatever voltage and it'll come in and regulate itself. Once you add the pins to the Arduino Nano, it'll just plug in there. So if you make any mistakes, you can simply pull this one out, put another one in. If you fry the Nano with, which I've done a couple, feeding too much voltage or drawing too many amps out of it, it'll cook them. So this is a nice little, even for prototyping, nice little thing to have. The other thing I used is this little heatsink. I was having trouble finding a heatsink, so I actually have some old computer boards lying around, and I pulled off the heat sinks that are off the front side bus and the onboard display adapter, and so I pried them off and basically took a hacksaw to it, cut it, ground it down, drilled a hole through it, and attached it to that LM7805 voltage regulator, because it actually does generate a lot of heat. Right now it's currently driving 5 volts through the whole system, so not only is it driving the LEDs, but it's also driving this pilot relay and the voltage the pilot relay requires to pull the coil in. So it's doing a fair bit, and it is getting warmer. Right now it's probably about 80 to 90 degrees right now, and by the end of this test it'll actually heat up a little bit more. We'll discuss the software problem that I had when you buy these chips, the Arduino Nano. If you cheap out and go on eBay, you will find that they use the CH340 chip on the back. This is the FTDI chip that when you insert your USB into it, this is the communication chip that syncs it to your laptop or desktop, whatever you're communicating with. The original one that comes with the factory certified Nanos and things like the Arduinos, like this is a true Arduino, as well as this one over here. They are quite, more expensive, but you'll find that they're, better build quality. Although when you start throwing them out, they'll start throwing projects out, and you just want something cheap and easy. You basically migrate to these little $5 microprocessors. So this chip requires its own USB driver. When you plug this chip into your PC won't recognize it. The Arduino software does not recognize it. It doesn't come with the appropriate drivers for this. It will come with the drivers for the Arduino, the official Arduinos. Oh, there we go. Just talk about this for a second. Just hit this alarm reset and everything shuts off. Oh yeah, and just to note that this did shut off, that shut off, everything's back to normal, and it's ready for the second test. So Arduino software does not recognize this, and it doesn't have the drivers for it, so you'll have to go online and find the drivers for it. Basically, the easiest way to do it is either type in the CH340 driver into Google, and you'll have several links that'll come up, and if you're lucky you'll find the right one. But what I ended up doing was going on eBay, looking at the Arduino Nano chip from the sellers, and in the comments section they usually have the links that will send you to where the drivers are located. The one problem that I did experience when trying to load this is when you plugged it in and you tried to upload the sketch, it just kept timing out 10 times, then it would just give up. So what I found the problem was that you got the RX and the TX LEDs here. When the RX button was lighting up, it's basically receiving the signal from the Arduino sketch. What I eventually ended up doing was, from another YouTube person, was I pressed the reset button, hit the upload sketch. As soon as this LED, the receive LED, lit up, I would release the reset button, and that would be enough to trigger the upload. And it worked. It took a while to figure that one out, but it does work, and the Arduino Nano does work, does function properly, and it works really well. But in the future, I may just buy the original Nano and support everything that they do. Yeah, so that's basically the system as a whole. Oh, the other thing I don't know if I mentioned, that these relays are low active, so the input actually grounds. If you ground the input, you got the VCC, which is where you send your 5 volts. This is a 5 volt relay. So send your VCC 5 volts, put your ground on your ground, and then your input, as soon as you ground that input, this will trigger. It has a circuitry on it that it will do that. One thing I didn't realize with the Arduino environment, the digital pins, when you write them as an input or an output, sorry, as an output, because I wanted an output to drive this relay. When you write the code to the output, you set it as low, LOW, and when you set it low, it actually takes that pin and grounds it, and that's how these will trigger. If you send it to high, it actually will send 5 volts, digital 5 volt out, and which will do absolutely nothing. I've put 5 volts on these relays and they don't do anything. But as soon as you ground it, as soon as you send it to low, they trigger just quite fine, and they do their job, and hopefully that helps you out, because I did not find that. I was looking for quite a while, and it was just an obscure reference in some text somewhere that's where that was. So I hope this demonstration and that information is helpful to you, and this is heading off to work, where we'll start using this next week. Thanks.